square.
Out the length of AC. Give your answer to 3 significant figures. So remember, you'll have your formula sheet at the front of the exam. What we want to try to use here is the cosine rule, and we know that because you're going to have this side, and we need to find AC, which is this side. So we've got 3 sides involved and the angle. So we've got A squared equals B squared plus C squared minus 2BC cos A, and we're just going to substitute them values in. It doesn't matter which way round you have B and C, so we'll have this as B, this one as C. We're going to cross this out and rename it A, and we're going to rename the opposite side small a. So we've got B, which is 26 squared, plus C, which is 15 squared, minus 2 times 26 times 15 times cos 98. That's going to equal 1009.55 ... with some other numbers, and remember that's A squared. So quite simply, once you got that answer on the calculator, just square root it, and that'll just give you A rounded to 3 significant figures. So if we square root that answer, that gives us 31.77, and that rounded up to 3 significant figures will be 31.8 for A. Okay, so the diagram shows us triangle PQR. Calculate the length of PR. Give your answer correct to 3 significant figures. So again, we've got a side, we've got a side. We want to find this side, and we've got an angle. So this one has got 3 sides involved, so we're going to use the cosine rule. So again, we're going to write A squared equals B squared plus C squared minus 2BC cos A. Doesn't matter again which side you have for B and which side you've got for C. We're going to cross this Q out and label that A and the question mark as small a. So we've got 26.3 squared plus C squared, which is 17.8 squared, minus 2 times 26.3 times 17.8 times cosine of 36. Hit this in our calculator. This should give you 251.06 with some other numbers. And remember, you just need to do the square root of this to get what A is, and that gives us the square root of that answer, gives us 15.8, and remember that will be to 3 significant figures, and that's your final answer. Okay, so factorize 2x squared plus 5x plus 2. So this is harder factorizing where the coefficient of x is more than 1. So step 1, we're going to do 2 times 2, and that gives us 4. So we're going to times to make a plus 4, and we're going to add to make a positive 5. Combination to times to make 4 is going to be 1, positive 1, times positive 4. That times to give you 4, and it combines and adds to make 5. So tick, that works. With harder factorizing, you would put 2x squared to begin with. Take one of your numbers from the table and put x after it. Doesn't matter which way around, you'll still end up getting the same answer. Then plus 1 with the x after it, and then the original ending, which was plus 2. Then we're going to draw a dotted line and we're going to factorize either side. So 2x can come out of there, and 2x times x gives us 2x squared. 2x times 2 gives us 4x. Copy and paste this bracket of x plus 2, and then you have to see how do you times a number to get to x plus 2. Well, that's just going to be plus 1. So now your solution is what's on the outside of the brackets. 2x plus 1 is one of your brackets, and you take one of these brackets, x plus 2, and put it next to it, and that will expand out to give you 2x squared plus 5x plus 2. So we're going to factorize 2x squared minus 7x plus 6. So step 1, you're going to do 2 times 6. 2 times 6 gives you times to make 12, and add to make minus 7. So your combination to make 12 is going to be minus 4 times minus 3. Minus 4 times minus 3 will give you positive 12, and it will combine to give you minus 7. So now you're going to put 2x squared, take a number from the table and put x after it, take the other number, minus 3, and put an x after it, and you want the original ending plus 6. You draw a dotted line and you factorize either side. So you're going to pull out a 2x. 2x times x gives you 2x squared. 2x times minus 2 will give you minus 4x. Copy and paste that bracket over. And then from x minus 2, how would you get to minus 3? Well, you're going to times it by minus 3. Minus 3 times x gives you minus 3x. Minus 3 times minus 2 will give you plus 6. So your answer is going to be the terms from the outside will make one bracket, and then your other bracket is just going to be x minus 2. And that will expand out to give you 2x squared minus 7x plus 6. Okay, so prove algebraically that the recurring decimal 0.78 recurring can be written as 26 over 33. So step 1, we're going to write x is equal to 0.78 recurring. And what we need to do is try to cancel out the recurring. So then we're going to multiply this by 10 to give us a 10x. That will move in place value to give us 7.87. If we were to subtract this, this would not cancel out. So what we would do is we would times it by 100, and that would give us 100x, which is going to be 78, and that's going to give us the 7.8 recurring there. If now we do the 100x, which is equal to 78.78 recurring, subtracting the x, which is 0.78 recurring, that's going to give us 99x, which is equal to 78. We will divide this by 99 on both sides. That will give us x equals 78 over 99, and that will simplify down to 26 over 33. Okay, so use algebra to show that the recurring decimal 0.254 recurring equals 14 over 55. So if we get x equals 0.254 recurring, 10x is going to equal 2.545 recurring, 100x is going to equal 25.454 recurring, and here we can see that the 5,4 is going to cancel out, so we're going to end up having 100x minus x. So we'd end up with 25.454 recurring, subtracting the 0.254 recurring. That will give us 99x is equal to 25.2. Divide that by 99 on both sides. That'll give you x is equal to 25.2 over 99, and that should simplify down to 14 over 55. Here are the first 5 terms of an arithmetic sequence 7, 10, 13, 16, 19. Find the sum of the first 100 terms of this sequence. So remember, you're going to get the formula on your front sheet where A equals the first term, D is your common difference, and N will equal what you're looking for, which is 100. So we're going to just substitute that into the formula. So 100 for N over 2 bracket 2 lots of A, which is the first term, which is 7, plus 100 minus 1 times the common difference of 3. We're going to simplify this down. 100 divided by 2 is 50, times bracket 2 times 7 is 14, plus 100 minus 1 is going to be 99, times the 3. Hit this in your calculator and you should get 15,550. So here are the first 5 terms of an arithmetic sequence 3, 7, 11, 15, 19. Find the sum of the first 30 terms of the sequence. Remember, you've got the formula on the front sheet, and A equals your first term, D is your common difference, and N stands for what you're looking for, so the first 30 terms. And again, we're just going to substitute this into the formula. So N is 30 over 2, 2 lots of A, which is your first term, which is 3, plus N 30 minus 1 times your common difference, which your common difference in this question is 3 to 7 is 4. We're going to simplify that up. 30 divided by 2 is 15, 2 times 3 is 6, plus 30 minus 1, which is 29, times 4. We hit that in our calculator, we should get 1,830, which is the correct answer.